Okay, so the last question I have for the sample paper E is question 14. So enzymes are biological catalysts that help reactions to take place at relatively low temperatures. This explains why they are used in biological washing powders. Hydrogen peroxide is a poison that can build up inside living things. An enzyme in the liver can break down this toxin very quickly. So we have hydrogen peroxide breaking it into water and oxygen. Describe how this could be demonstrated in the laboratory. As part of your description, draw a label diagram and name each piece of equipment used. So we did this setup with producing carbon dioxide gas. Okay, so difference here is that, and we did look at making oxygen gas, we just didn't actually do it. So for my carbon dioxide, I have two substances that are used. The first one is calcium carbonate or marble chips. And the second one then that we had was hydrochloric acid. Okay, we looked then also at oxygen, and two different chemicals are used for oxygen. The first chemical that's used is called hydrogen peroxide. And the second one is manganese, okay, not magnesium, but manganese dioxide. Okay, so we did do this, we just didn't actually make the gas. So inside here, this is my Buchner flask, okay, and I have my two chemicals, hydrogen peroxide and my manganese dioxide. Remember, my manganese dioxide acts as a catalyst, okay, and an enzyme is simply a biological catalyst, so biological in living things. So I have my hydrogen peroxide, here I have my manganese dioxide, and I collect it in a beehive shelf over water, and that is a test tube overturned and filled with water. And what I notice here is that I end up with oxygen gas being given off. The gas produced during the reaction is oxygen. Describe a test for this gas. Oxygen always relights a glowing splint. If you're asked for carbon dioxide, the test for carbon dioxide, even though you're not, is that it turns lime water milky. And finally, if you are asked for hydrogen, again, we're not in this question, but these are ones you need to know. It burns with a pop. Okay, so that is those there. Over the page then, we're looking at question C. The reaction will show an increase in temperature. Is the reaction endo or exo? It's exothermic because all exothermic reactions produce heat. Next then, we're asked to draw an energy profile diagram and explain how a catalyst can increase the rate. So on my y-axis, which is my vertical, is energy. On my x-axis, which is horizontal, is my progress. This here is my reactants. Okay, they're going to react and they need a certain minimum energy to react, and then they produce products. Okay. This here from the line of my reactants to the top of my curve is called my energy of activation or my activation energy. And if I look at a catalyst lowers the activation energy. So without the catalyst, my activation energy is higher. With the catalyst, my activation energy is lower. And I have them indicated here, which one is which. This is an exothermic reaction because my products line lies below my reactants line. If I was to do an endothermic reaction, my products line is above my reactants line. Okay, again here, if you did, you could do this. And my energy of activation, again, is to the height of the curve. And that is with a catalyst. Okay, and your delta H here is here. Delta H here is there.